Children, let's focus on the next question. Quite interesting, children, quite interesting. This can be considered as one of the hots in ratio proportion. That's what Refresh Concepts is all about. Not only we give all the basic content, basic explanation, basic sums, at the same time we also give you answers to hots as well. So there are many such hots in our refreshconcepts.com, right? Stay tuned, log into refreshconcepts.com. We move on to our sum. If A, B, C are in continued proportion, prove that A square plus B square plus C square upon A plus B plus C is equals to A minus B plus C. Hence or otherwise, find three numbers in continued proportion, having a sum 19 and having sum of their squares as 133. So what we have in this particular question, we have to tackle down two parts. What is it? First, we need to prove this one, that is A square plus B square plus C square upon A plus B plus C is equals to A minus B plus C. It's after that they have used two words, hence or otherwise. In maths, children, whenever they make use of the word hence, it means that we have to make use of whatever we have proved it in our question, right? So here being stated, hence or otherwise, find out three numbers. Find out three numbers which are also in proportion, continued proportion, right? And sum of those three numbers is 19 and sum of their squares is 133. So that is the second part we are supposed to find. First, focus on the first part, which is to prove. We all are aware many sums is what we have done to prove sums by K method, right? Earlier we have proved many such sums where the numbers were in proportion or continued proportion. We have proved it by K method. So my students are very much versed with K method. To start off with, we have already written from first ABC in continued proportion by K method. A by B is equals to B by C, which is K. K is a non-zero constant. B by C is K, which implies B is CK. A by B is K, which is A equals to BK. Since B is CK, A finally turns out to be as CK square. Equation 1, equation 2. Let's start our to prove. So what is A square plus B square plus C square upon A plus B plus C is equals to A minus B plus C. Earlier in my videos, I have mentioned one technique. Children, what was that? Whenever, if it is possible from your side to gauge whichever is simple, either LHS or RHS, try to solve that first. Didn't I? Right? Refresh your concepts. I have mentioned in many videos earlier. So here, when I'm looking at my LHS and RHS, I find my RHS being very simple. So what I'll do is I'll solve RHS first so that I'll have at least an idea what could be the final answer of my LHS. I've told you the reason behind it, right? What could be the final answer of my LHS? So let's take RHS first rather going with LHS. So RHS. What is RHS, children? A minus B plus C. Now what is A? A is CK square minus B, which is CK, plus C. There is no substitution for C. There is substitution for A and B. From where did you get this? From equations 1 and 2. From equations 1 and 2. What next, children? Can I take C common? I'm left with K square minus K plus 1. I'm left with K square minus K plus 1. Now I can't go for any further either cancellation. There is no cancellation possible. There is no further solving also possible. So this is what my RHS is. Let me take this as equation number 3. Right? So what should be the final answer for my LHS? My final answer for LHS also should be C into K square minus K plus 1. Right? Let's start. LHS. Sum is very good, children. So be very attentive when I make you understand all the steps in LHS. LHS is A square plus B square plus C square upon A plus B plus C. A CK square, so CK square, square of that. B CK square of that. C square as it is. A CK square, B CK, C as it is. From where did you get this? From equations 1 and 2. From equations 1 and 2. What next? Is this square applicable to both the terms inside, both the variables inside? Indeed, yes. C square k raised to 4. C square k square plus C square upon ck square plus ck plus c. What next? Can I remove c square common from the numerator? So we try to remove c square common. When I remove c square common from the numerator, what I have? K raised to 4 plus k square plus c square common, I'm left with 1. How about denominator? C common, I'm left with k square plus k plus 1. Right? Can I cancel c? Indeed, yes. C gets cancels off. Mind you, only one c gets cancels off. We are left with one more c. Only one c gets cancels off. This c gets cancels off. Mind you, earlier it was 2. Gets cancels off. We are left with one more c. So I'm left with c, and then k square plus k raised to 4 plus k square plus 1 upon k square plus k plus 1. Children, this is the technique which I said earlier, and I proved many a times earlier also. This is what my RHS is, so my LHS also should be this. Are we very nearby to it? No, nowhere near to it. So there is something, we are not wrong, mind you, there is something which needs to be solved further. We are not at all wrong, but yes, this sum, as I stated earlier, it's a kind of HOTS, right? So what needs to be done? This is a polynomial with degree 4, and I have to have something of degree 2 as my final answer. So this requires good amount of factorization. The method which I say right now, or the word which I use, keep this in mind, this is termed as compensation. Please pay attention what I'm going to do right now. This is termed as compensation. So we are saying C as it is. We are saying k raised to 4 plus 2k square. Sir, you have only k square, I know, but I'm writing 2k square plus 1 minus k square. What did I do? I had earlier mentioned 2k square minus k square. So ultimately I'm left with plus 1k square only. So I'm compensating please plus 2k square minus k square. Sir, why did you go for this? I'll give you an answer for that. I'll give you the answer for that. But before that, what is the denominator? Nothing, as it is. As it is. What made me write down in this way, children? Why did I go for this compensation? Here is the answer. This C as it is. Now children, when I take these three 2k square plus 1, it is nothing but square of k square plus 1 the whole square. It's square of the binomial k square plus 1. Check it out. If a plus b the whole square, answer is a square. So k square ka square, k raised to 4. Plus 2ab, so 2 into k square into 1, 2k square. Plus b square, 1 square. Now sir, why did you want this particular a plus b the whole square? I have an answer for that also. But let's finish off. So k raised to 4 plus 2k square plus 1 will turn into k square plus 1 the whole square minus k square upon, within the denominator, no change, k square plus k plus 1. Children, why did I do so? Converting into a square minus b square. A square minus b square. A minus b, a plus b, c, then a plus b, so I am writing a, which is k square plus 1, plus k. So avoiding one step of rearrangement. So those who can't understand, I'll write down once again. It is a square minus b square, a plus b, k square plus 1, which is a plus b, and a minus b. What I had written earlier was k square plus k plus 1, rearranging it. Right? How about denominator? K square plus k plus 1. Children, k square plus k plus 1, k square plus k plus 1. Can I cancel it? Very much, children, very much. Can I rearrange the numerator once again? And I'll arrange the numerator as c into k square minus k plus 1. Check it out. C into k square minus k plus 1. C into k square minus k plus 1. This is my equation number 4. This is my equation number 4. This is my LHS though. This is my LHS. From 3 and 4, my LHS is equals to RHS. Therefore, I can say we have stated our question. A square plus B square plus C square upon A plus B plus C is equals to A minus B plus C. We have proved it. Our sum is not yet done, children. Our sum is not yet done. We have just proved half part. Let me say this as my equation number 5. As I'll be using this in my further. Why? Because they stated hence or otherwise. And what did I started with my video with? Whenever they make use of words such as hence, that means we are going to make use of things which we have proved it. So let me say this is our equation number 5. What next? The question has to say. Find 3 numbers which are in continued proportion. That's what we are supposed to find out. Whose sum is 19. So let the 3 numbers be A, B and C. So given that A plus B plus C is 19, equation number 6. Next, sum of their squares is 133. So also given that also A square plus B square plus C square is 133. These two things are given to us. Children, what if I substitute both equation 6 and 7 in 5? What if I substitute equation 6 and 7 in 5? I'm having A square plus B square plus C square as 133. So in the numerator I'll have 133. I'm having A plus B plus C as 19. In the denominator I'll have A plus B plus C as 19. Can I say from 5, 6 and 7, from 5, 6 and 7, can I say A square plus B square plus C square upon A plus B plus C? So it is 133 by A plus B plus C. 19 is nothing but A minus B plus C. On cancelling 1 times 7 times, finally I get A minus B plus C as 7. Let me say this is my equation number 8. Let me say this is my equation number 8. Right? What next, children? With equation 8 and equation 6 into account, what if I subtract? What if I subtract equation 8 from 5? Sorry, equation 8 from 6. What if I subtract equation 8 from 6? So subtracting equation 8 from equation 6. So when I subtract 8 from 6, that means I want A plus B plus C minus A minus B plus C. On doing so, what will I have? A plus B minus C is 19 minus 7, which is 12. But if you open down the bracket, plus A minus A will get cancels off. Plus C minus of plus minus C will get cancels off. Minus of minus plus 2B. So when you open down the bracket, children, I'm writing it directly. 2B is equals to 12, which implies B is equals to 6. This is my first answer. This is my first answer. I got my first answer, B as 6. What next? On subtracting 6 from 8, if I get the value of B, let's add 6 and 8. Let's add equation 6 and 8. Now adding equations 6 and 8, we get what? So let's see. When I add 6, it's A plus B plus C plus A minus B plus C. A plus B plus C, answer is 19. The above one answer is 7. When I add, don't you think so? Plus B and minus B gets cancels off. I shall have A plus A, 2A. I shall have C plus C, 2C, 2 common. Twice A plus C is 19 plus 7, 26. On dividing by 2, A plus C is 13, which implies, on dividing by 2, A plus C is 13, which implies what? Either A is 13 minus C or C is 13 minus A? Your call. Your call. It's totally your call. So I shall say A is equals to 13 minus C. Let this be my equation number 9. Let this be my equation number 9. What next, children? Now, what according to you I should do? We have new equations. We have A plus C. We have substituted. Now what next? We have B with us. We are being told that three numbers are in continued proportion. We have B with us. We have A in terms of C. Since A, B, C are in continued proportion, can I say B square is equals to AC? Which implies B is already known to us. Let this be equation number 10. Substitute 9 in 10. Equation 9 in equation 10. 36 is equals to A is nothing but 13 minus C into C. 36 is equals to 13C minus C square. Bring this here so as to get a quadratic equation. C square, I'm so sorry, it's 13C. This is 13C. So C square minus 13C, C square when comes here, minus 13C plus 36 equals to 0. The factors are minus 4, minus 9. The factors are minus 4, minus 9. I'm writing it directly. C minus 9, C minus 4 is 0. Therefore, C equals to 9 or C equals to 4. When C is 9, then what will happen? When C is 9, then A is 13 minus 9, which is 4. When C is 4, then A is 9. So what are the three numbers? B is constant, 6, mind you. Therefore, the three numbers are, if I start with C9, A4, B6, so three numbers are 4, 6, 9, or if I start with A9, so 9, B6, C4. Right? The three numbers are 4, 6, 9 or 9, 6, 4. So don't you think so? That sum is genuine good sum? We have many more like this.